Hello, so welcome to this video. So on this video I'll be discussing whether free will exists, and we'll be breaking it down into multiple steps considering lots of different views. Although this video will be principally from the perspective of physics, because the nature of free will is directly related to a couple of concepts in physics, although those concepts are not particularly in favour of free will. So that's what we'll be looking at in this video, and we'll cover things like superdeterminism, reductionism, how compatible ancient Greek ideas of the soul is with our current understanding of biology, all in this video. So the topic of free will is very broad, because there's actually lots of different facets as to what physics and modern science has to say on the subject. And naturally the idea of free will goes back even further than modern science. I would reckon people have been wondering about free will since humans first developed any kind of social society. So essentially free will has always been on the minds of humanity. And for a while it seemed like, well, free will probably exists just because there is, a huge emotional weight behind the idea of free will, and most people feel like they are capable of choosing between various options, and that when they act, they are genuinely capable to have made a different decision. So let's look at the journey we'll take towards looking at, does free will actually exist, and in what ways might it exist or might it not exist. And the steps are, we first look at reductionism. Now reductionism is kind of the idea that when we have a large structure, such as a pool of water, we can break that pool of water down into molecules of water, but by understanding really the quantum structure of a water molecule, we can in principle rebuild all of the properties of a large group of water molecules. So we can recover things like the viscosity of water, the density of water, and all those other things. And this idea in science is very powerful, because if we understand something at its fundamental levels, we can then predict how that large-scale thing will behave in new environments, where we haven't seen the large structure much before. And that's led to, for example, ideas like hydrogen in principle becoming metallic at high temperatures and pressures, far beyond the temperatures and pressures we usually subject hydrogen to. And that has, I think, yet to be experimentally confirmed if hydrogen does this, but we can make a prediction based on our understanding of hydrogen molecules at, their simplest and most fundamental level. Reductionism also helps us make predictions about semiconductor materials that we can actually test and make use of to design new technologies. So reductionism is very powerful. But what reductionism does imply is that the properties of the fundamental constituents of things determines the properties of a large-scale structure made up of those tiny things. So if we're asking, does an organism have free will, we need to ask, is there some way when we look at the subatomic structure of the molecules and atoms the organism is made up of, do those subatomic constituents have free will, or can they act in such a way to allow free will to exist? And then we'll be looking at a bit more deeply, does quantum mechanics really give us any ideas on whether free will exists or not? Can quantum mechanics save free will from a deterministic, reductionistic view of the world? And then we'll be looking at superdeterminism, which has been popularised, but I think also mostly developed, though I could be wrong on this, but I think mostly developed by Sabine Hossenfelder. And then lastly we'll be bringing a bit of ancient Greek philosophy, talking about two models of the soul, because there's actually quite different ways to look at the soul. Plato had his idea, and Aristotle had his picture of the soul, and we'll be talking about both of those. So this video is going to be a mix of physics, philosophy, and potentially, if I can, a bit of mathematics. But we will finish up by looking at the soul at the end of this video. To represent the soul, I've used an image of the spirits in the film 200% Wolf. I would highly recommend anyone who hasn't seen it to check it out. I think it was in cinemas a few months ago. I saw it a couple of times. It's really amazing, quite awesome, and wolves are awesome anyway. But anyway, let's start by talking about reductionism. I'm thinking, does reductionism indicate that free will exists, or does it say free will probably wouldn't exist and our perception of free will is an illusion? So we're now going to start talking about the concept of reductionism. Now, reductionism, it's worth saying, is an assumption that science tends to make. It's a hugely successful assumption, because by using macroscopic experiments, we can sometimes directly understand something about the microscopic realm, an example being the photoelectric effect, where due to the nature of photons, although in the photoelectric effect you're using a huge number of photons and the light seems classical visually, actually the interactions that lead to the photoelectric effect only involve single photon, or one-on-one interactions between a photon and a delocalized electron in the metal that is experiencing the photoelectric effect. So we can sometimes actually, thanks to how particles interact, even when we're doing macroscopic experiments, test the microscopic world directly, but also by studying the macroscopic world, we can infer things about the microscopic world, and from those inferences we can then we can predict that a macroscopic object will behave in a particular way under conditions we haven't usually seen it in before, and often indeed, yes, our predictions based on what we assume about the microscopic world do lead to a correct prediction about how a macroscopic object will act based upon its microscopic constituents. So reductionism is the idea that emergent phenomena, such as, maybe the conductivity of a metal at a particular temperature, or it could be the heat capacity of a gas, or how the heat capacity varies under fixed volume vs fixed pressure. So some macroscopic property can ultimately be described or predicted from an understanding of the constituent particles that make up that macroscopic object. And this idea is really successful. It's at the foundation of a branch of physics called statistical mechanics, which essentially looks at how probabilistic rules about the microscopic world can lead to nearly definite statements about a macroscopic object. Because when you have a large number of particles, a probabilistic description becomes a pretty much exact description about what those large group of particles will do. And there are many examples of reductionism at play, so the non-reactivity of noble gases is an example. Now, with noble gases as our example, it's worth mentioning briefly what the noble gases are. So we have helium, neon, argon, I think krypton is one of them, although krypton doesn't have an ability to steal the powers of Superman. Krypton, in fact, doesn't really have many abilities at all as part of the noble gases. Helium is an interesting example of how unreactive noble gases are. One of the reasons why, if you had a balloon and wanted to travel into the sky or something, you might want to use helium, or why we use helium balloons anyway, is because helium is incredibly unreactive. It was actually first detected by looking at its emission spectrum within the sun, hence the name helium from Helios, a name for the sun. So these noble gases are incredibly unreactive, and if one looks at the electronic structure of the atoms that make up the noble gases, it's clear why. So noble gases have a fallout shell, and this essentially means that their outermost shell is at a relatively low energy. And for noble gas to bond, it would have to either add electrons to a further shell, but it's already got fallout shell, so this wouldn't really help the atom lower its energy, or the atom would have to destabilise its outermost shell, and that's not something the atom wants to do, because that wouldn't lower the energy of the atom. In fact, that would increase the energy quite substantially. So noble gases are generally, it's worth saying, when you bring in other atoms, sometimes these noble gases will react if the other atoms are extremely reactive, and that's because the destabilisation, if you like, of the noble gas is actually, results in an energy increase, but a much smaller energy increase than the energy loss in the other very reactive elements. So, for example, noble gases can react with fluorine. It doesn't mean they usually have a propensity to necessarily do so, but this can be done. but we are able to determine, well, we're able to explain the non-reactivity of noble gases based on the electronic structure, and the explanation of the idea of wanting to have a full-outer shell, although that's not the entire picture of stability and bonding, but as a general rule of thumb, it's a good one. The idea of elements being made up of atoms that want to gain a full outer shell helps us understand why, for example, water would exist, H2O, but a hydroxyl molecule, so just HO, wouldn't exist, or at least would exist for such a short amount of time because it'd be so unstable. For all practical purposes, it wouldn't exist. So we are able to determine a very macroscopic property of an object, like its reactivity, from how its subatomic particles are organised. So this is an example of where reductionism seems to work very well. But it's worth saying reductionism is fairly counterintuitive. In that often it takes a lot of probing to understand how the organisation of microscopic structures or properties these microscopic structures have, such as charge and mass, will lead to properties of large-scale structures, like a pool of water. And this difficulty is emphasised by one of the founders of statistical mechanics, who was deeply interested in, understanding the link between the microscopic and macroscopic. A person named Ludwig Boltzmann. He decided in the end to take his fate into his own hands, which may or may not have had something to do with his involvement in statistical mechanics, because as anyone who has done a bit of statistical mechanics will probably appreciate, statistical mechanics is, I would say, a nightmare. And it's a nightmare because whilst there's a lot of maths, it is also incredibly non-intuitive. It's very, very hard to determine whether what you're doing in statistical mechanics is correct or not. Statistical mechanics can also lead you to predict very unexpected properties. Statistical mechanics is one of the least intuitive branches of physics. I would say even less intuitive than general relativity, because, at least with general relativity, we understand intuitively a weak field approximation of the curve space-time general relativity deals with. That is, we understand gravity found intuitively, to a degree at least, because we encounter it every single day. Whereas statistical mechanics, because we've never actually physically journeyed from the microscopic to the macroscopic world, statistical mechanics is highly non-intuitive. And what that says is something very important. It says that bulk properties of materials or even organisms might seem completely disconnected from microscopic properties. That is, unless we put a huge amount of effort, time and research into a macroscopic property that is derivable in principle from microscopic properties, we might never work out what those principles are. And it would seem like that macroscopic property doesn't have any relation to the microscopic constituents. And that's important to bear in mind when we're talking about free will, because free will, at least as far as we can seemingly determine, is an experience felt by macroscopic organisms. And it might seem like that experience has nothing to do with the microscopic particles of which organisms are made. However, reductionism shows us that microscopic structure and properties can lead to very unexpected macroscopic properties. So, free will it might feel like free will might be associated with something beyond the natural world, perhaps something spiritual or supernatural. It might, free will might give the impression that humans have something fundamentally different, like a soul, when compared to things like microphones or tablets. However, the fact that statistical mechanics is so difficult clearly shows that we can't just go, well, free will feels so alien in terms of its relation to microscopic properties, so free will can't be generated from properties of microscopic particles, or at least a sensation of free will. I'm trying to be careful here by talking about sensation, because as of yet I haven't said whether reductionism implies there's free will or not. I will do that on this coming part of the video. So now we're going to look at, does reductionism, the idea that we can essentially reduce a large variety of macroscopic properties of objects down to rules about how the microscopic world behaves. We now are ready to talk about, does reductionism imply that free will exists? Or does it rule the idea out? To discuss this, I've got a picture here showing deep underground, a part of the particle collider at CERN, and you have lots of different particles being scattered, which is, I think, what that blue haze is meant to represent. But the idea is that essentially, even the Large Hadron Collider itself, it's made up of lots of different pieces of equipment, but those pieces of equipment work in a way that in principle can be derived if we just knew all the properties of the atoms and molecules making up that piece of equipment. So that could imply that if the particles have free will, then the objects they make up might also have free will. And this is an idea known as panpsychism. Now, it's worth saying you could also say that free will is emergent from the arrangement of particles. And so the particles in and of themselves don't have free will. But I'm going to start off with the simplest link to reductionism and free will, which is the idea of panpsychism. So panpsychism says that particles can display a rudimentary sense of free will. And, whether panpsychism is true or not is debated, but it's worth saying I firmly stand on the fence that panpsychism is false. And I think most physicists would. And that's because when we do scattering experiments, where we look at the behaviour of particles, and when we use those results to develop theories to make predictions about how different types of interactions will occur, and then those are confirmed by experiments, it really seems like particles are following the rules of quantum field theory, a branch of physics that unites special relativity with quantum mechanics. So, is there any free will allowed in quantum field theory? And the answer is, well, at least at fundamental level, no. That is to say, if we're just looking at the properties of the particles, we're not talking about how the particles are arranged, but we're just talking about the individual properties of the particles. There's nothing within quantum field theory that seems to necessitate free will. In fact, if particles do have free will, then they have free will in such a way that they act entirely in accordance with rules we can predict ahead of time through the mathematics of quantum field theory, which unless particles have a conspiracy on their hands and are just trying to hide the fact that they have free will, to me implies that particles don't have free will. They are just following the rules provided by quantum field theory. And to insist that they also have free will, well, one, it doesn't explain anything because there is no observational effects that seems to imply particles have free will. And yeah, I don't see how panpsychism can be true unless particles are just going along with the ideas of quantum field theory to fool physicists. Also, for me, free will is one of those areas that I feel if particles had free will, not only should that become evident in scattering experiments, but since particle physics underpins every type of matter, including solid state physics, soft condensed matter physics, so many different branches of physics that deal with everyday objects and organisms. If particles did enjoy free will and were actually using that to make decisions, that would be catastrophic for the world, the universe, which relies on the idea that, well, it would be catastrophic for the universe as we know it, because it would mean that the chemical properties of atoms and molecules would keep changing because electrons would keep choosing to do different things outside of the mathematical dictates of quantum field theory, and so essentially I wouldn't be able to be here long enough to make this video if particles had free will. So I think panpsychism is fairly conclusively either completely redundant or utterly false. So I think we can say fairly confidently, although it is debated and this is only my view, but it is shared by many physicists, I think we can fairly confidently rule out the idea that if free will exists, that free will originates from just the properties of the fundamental particles. But now we're going to talk a little bit more about, well, could free will arise from the arrangements or correlations between subatomic particles, and here things get really very interesting and fairly abstract. So we've mentioned that arrangements might be something we need to consider in terms of looking at whether we can get free will through reductionism, so through looking at the microscopic properties of the microscopic constituents of matter and ultimately organisms. Well, it's worth mentioning, if we're bringing in the microscopic, to talk about particular kind of arrangements that are allowed by quantum mechanics. So quantum mechanics allows for very special correlations, really, between particles which have recently interacted, where essentially information about the combined system cannot be reduced to information about the individual particles. So entanglement is almost, if you like, a form of anti-reductionism, which makes it quite special. Entanglement is a correlation that you can't get. It's a correlation which you can't break down into the properties or states of the individual particles that are entangled. So entanglement does indicate that there might be something wrong depending on the interpretation of quantum mechanics and therefore entangled states, but it might imply that there is something wrong with the idea of reductionism. That actually you can have properties of macroscopic objects that you cannot reduce down to the states of the microscopic objects. However, entangled states like, other states in the microscopic world, don't really seem to work with free will, because, entangled states obey the rules of quantum mechanics. So if you're taking the traditional approach, a entangled state will behave under observation entirely in accordance with the form postulate. So still, entanglement doesn't seem to give us free will, and entanglement can still be described mathematically. And I think this is something I'm going to keep coming back to, in that maths, well, if something is acting in accordance with mathematics consistently, at least I can't see a way for it to also be engaging genuinely with free will. And that's because mathematics deals with probabilities, and extreme cases of probability is really 1 or 0, so certain or impossible. So, even deterministic theories are in a sense probabilistic theories. It's just probabilistic theory where the only probabilities of events are either 1 or 0. Either the events have to happen or it's impossible for them to happen. But deterministic theories can be thought of as a very special case of probabilistic theories. And I don't see how probabilistic theories can even describe free will. I think there's a difficulty in terms of the language of maths to be able to describe free will, so entanglement doesn't bring us any closer to organisms having free will. However, it does indicate that actually maybe the idea of reductionism doesn't necessarily work but that is highly dependent upon your physical interpretation of entangled states. So whether entanglement is really a problem to the idea of reductionism, well, it partly depends on your philosophy, but also what physical meaning you assign to entanglement. And we'll be talking a little bit more about different approaches to quantum mechanics when we talk about superdeterminism, which is a fairly novel way of viewing quantum mechanics that has a lot to say about the nature of free will. But before we get there, I've often heard people say that, well, maybe quantum mechanics permits free will because quantum mechanics is a probabilistic theory in the sense of it allows probabilities that are not just 0 or 1. That is, quantum mechanics is deterministic, and at least in traditional interpretations of quantum mechanics is not a deterministic theory. So maybe that probabilistic aspect of quantum mechanics somehow permits there to be free will, where a Newtonian deterministic theory might not. But that doesn't really check out, and that's what we'll be moving on to now. So we've talked a little bit about quantum mechanics, but it's now worth bringing up a common argument used by people to say that quantum mechanics somehow allows free will in a way that classical mechanics might not. And this idea, I think, is a misconception, but it's an understandable misconception. So the thing that makes quantum mechanics fairly unique is that, as far as we know, quantum mechanics seems fundamentally a probabilistic theory allowing randomness. And it's not that randomness is generated by the equations leading to some kind of chaotic motion, it's that randomness seems the inherent part of quantum nature. And as a result, the way things evolve and interact in quantum mechanics means that there is multiple possible outcomes, and we might want to associate each possible outcome with a choice we could make. For example, if the electrical signal undergoes a particular pathway in our brains compared to other pathway, then we might say, well, the pathway the signal has chosen has led to a particular choice of action. However, the problem with this is that randomness actually jeopardizes the notion of free will, because for kind of something to be able to choose what it is going to do, the outcome of an event has to be related to a desired source of action by the organism. However, even if an organism acts in a particular way, due to quantum mechanics, we can't necessarily know what the result of that action will be. Now, most objects and most interactions are well approximated by classical physics, so there's a deterministic logic at play, but fundamentally, randomness isn't really associated with anything about the desires or views of an agent carrying out an action. And in that way, I think actually the randomness of quantum mechanics makes the problem of free will worse than it is in classical physics, because at least in classical physics there is a clear, consistent relationship between cause and effect, in that a cause is followed by a predictable effect that you know will occur from the equations of motion and other things. Whereas in quantum mechanics, if a phenomenon has happened, for example, let's say you observe a particle being released in a particular decay process with a particular energy, you can't actually use that to pin down the energy of the system before it decayed because of this quantum uncertainty. So in quantum mechanics, even if you have tons of information about the final state, you don't know what the initial state was that led to it, save in very special circumstances where there is only one way to get to a particular final state. And that can happen, but those are very much the exceptions. In most cases, there are many ways to get to the final state. So if you know the final state, i.e. if you know the effect, you can't know for certain the cause, you can't know for certain the initial state. All you can do is give probabilities of the initial states. And also randomness is, random, so it's not linked with the personality of a person or an organism or anything like that. So I think the randomness of quantum mechanics actually makes the issue worse, not better. Because in addition to quantum mechanical randomness not having any room for choice, quantum mechanical randomness also has no room for a clear and direct correlation between cause and effect. So, there's a multitude of problems at play if we look at standard interpretations of quantum mechanics. But there are other ways to look at quantum mechanics which go outside the standard interpretations, and one of them is the idea of superdeterminism, which is something I'm going to mention now. So superdeterminism is an idea that a few different physicists have worked on. The way I was introduced to it was by the physics researcher and YouTuber Sabine Hossenfelder, who has written many amazing books and has recently, well, I say recently, fairly recently at least, wrote a book called, I think, Existential Physics, talking about questions like free will and other questions that traditionally are associated with philosophy, but now we have a deep understanding of the physical aspects of biology, we can actually start using physics to at least get to some answers or ideas regarding those questions. So I would highly recommend checking out Sabine Hossenfelder's book. And I'm recommending it just based on her giving really amazing talks in the past and having a wonderful open mind to philosophy, which is something some physicists are great at and some others not so much. But anyway, let's talk about superdeterminism. Now, it's worth saying superdeterminism goes into incredible detail in relation to Bell's theorem, which I've come across and read, but I am by no means an expert in superdeterminism, so I will do my best to be accurate here. But from what I understand, superdeterminism is the idea that the choice of the measurements you make is correlated to the observables obtained. And that correlation ultimately extends back to, the Big Bang. Now this idea is important because Bell's theorem, which is used to often exclude the idea of local hidden variables, has a loophole. Because Bell's theorem does actually presume that what you choose to measure and what you observe have no statistical correlation between each other. It's the idea called statistical independence. But that's not necessarily true. I think, particularly if we think back to the early universe, things were much closer to each other. Local interactions could transfer information between things that are now very far away. So it's not ludicrous to think that there actually is a correlation potentially between two things that seem very different, the choice of measurement carried out by an experimentalist and the results of the observations. And so, by suggesting that there is this correlation, by getting rid of the idea of statistical independence, you can have a local hidden variable theory, which is essentially superdeterminism. And so in superdeterminism, quantum mechanics is interpreted as a local hidden variable theory. And local, by that I mean nothing is breaking the rules of special relativity. And due to this kind of determinism, I think about a superdeterminism because it's making quantum mechanics deterministic. Actually, there is fundamentally no real randomness in quantum processes. All that exists is a lack of clarity about this statistical relationship, because we might be able to go, well, there may be a statistical relationship between the experimentalist and the thing being observed, or the dial settings and the system itself. It might be completely impractical to actually calculate what that statistical relationship is. And so without that bit of information, it looks like quantum mechanics is random, or has randomness built into it, when in actuality, it doesn't. So in superdeterminism, essentially quantum mechanics is very like classical mechanics. It's just very like statistical classical mechanics in a way. And statistical classical mechanics deals with situations where statistical discussions get involved. I mean, it's a little bit different because in statistical classical mechanics, you often know or can calculate the statistical relationship or statistical description of a large group of particles that you're talking about. Whereas in superdeterminism, as far as I understand it, the statistical relationship is the thing you do not know. So it is a lot different. Very different in some ways. But ultimately, superdeterminism is as deterministic as statistical classical mechanics, in that there is no fundamental, randomness going on. It's just all a matter of statistics. And I think that's a rather core idea. We'll have to see how it transpires. But we talked so far a lot about physics that we can be familiar with. Now it's time to bring in more speculative philosophy, by which I mean, it's about time we talk about different models and ideas for the soul and see if that can help us in any way get to the bottom of the riddle of whether free will is illusionary or not. So, the soul is something where there have been many different ideas about how it functions over the years. Now, it's worth saying I'm calling this section of the video on the soul Plato's soul because it's more similar to Plato's idea of the soul than Aristotle's. But I'm being a bit loose with calling this model of the soul Plato's model. Plato used a tripartite model of the soul where he gave us a metaphor of somebody riding a chariot. And his idea was that the soul is kind of like three different things working together, one being reason, the other being the spirit, so what we might associate with kind of virtuous dispositions, and the last one is appetite, but appetite might also encapsulate something like ambition. And in Plato's idea, it seems like the soul is somehow like the truest description of a person, and he believed in the world of the forms, and thought that the soul originally existed in the world of the forms, and then when it entered, if you like, the contingent world, the physical world, it essentially had amnesia and forgot much of what it knew, which has to be relearnt. So, for example, when Plato was teaching mathematics, in his view, he was reminding the soul of things it once knew. And he tried to use this to describe why humans have an affinity for mathematics. Now, whether people agree with that or not, humans' ability to understand mathematics, even in its very abstract form, is definitely something worth investigation. But Plato's model for the soul isn't very popular now. Even people who may believe in heaven, which is something like the world of the forms, probably don't believe that the soul was in the world of the forms or heaven prior to it being within or linked to a physical body. But the way I try to think about Plato's model of the soul is it's kind of like Gandalf in Lord of the Rings. So Gandalf, bit spoilers here for the Silmarillion, but Gandalf was originally a Maya called Elorin, and when Gandalf came to the shores of Middle-earth, he forgot a lot of things, because his kind of power and knowledge was diminished, because his role was to help the people of Middle-earth unite and help themselves almost defeat Sauron. So, much of Gandalf's power was kind of cloaked, including a lot of his knowledge. But one idea from Plato which has remained very strong is this idea of a soul being present, which in some way is associated with the personality of an individual, and therefore necessarily to some extent their rational capability. Now today we know a lot more about the mind, so this idea we have to take much more carefully, but this idea of the soul containing somebody's personality ultimately, that's still preserved to today. And if that's the case, then maybe we have free will through the soul, because maybe free will can't be linked to the physical body, because as we've said, quantum mechanics is maybe at best super deterministic, at worst it's random, and in either case there is no room for free will present. Therefore the physical world doesn't seem to allow free will, so maybe something supernatural almost, maybe something outside of the quantum mechanical laws of nature will permit free will to exist. So maybe the soul's a solution. So that's kind of like my proposition. And I think if we establish whether this proposition can be true, let's think about a possible consequence of it. Let's almost do what might be called a proof by contradiction. Let's presume proposition 1 to be true and see whether we get something that contradicts something else we know. So a consequence of proposition 1, as far as I can tell, is like, as the soul seems fundamentally disconnected from the physical world, or at least the soul isn't a part of the physical world, it should mean if somebody encounters some kind of injury, for example, to any physical organ such as the brain, then because the soul is a physical, no damage will occur to the soul. And if personality and free will and choice is interlinked with the soul, that will mean that the personality of somebody shouldn't necessarily shift if they have a severe brain injury, for example, in some kind of crash or something. Now, the unfortunate thing that we can clearly, see enough to be convinced that this isn't just a fluke, is that severe injury, particularly to the brain, to the physical brain, does lead to changes in behaviour and personality. Sometimes quite drastic changes. Now, that's not particularly surprising if we assume, what somebody does or chooses to do is fundamentally a consequence of the physical state of their brain, and therefore if their brain gets severely damaged, that physical state will change, and consequently their behaviour or personality will change as a result. I think if we're thinking about kind of like those kinds of injuries, proposition 1 just doesn't make sense, because if proposition 1 would be true, well, brain injuries would be far less of a severe thing in many instances, because brain injuries wouldn't actually change the personality or self of the person who's had the injury. I think we have to discount proposition 1 and go, no, personality, self, and therefore decision making is inherently linked to the physical brain. And if you alter the physical brain, the link is strong enough to then alter personality and decisions people consequently make. So, I think proposition 1 is untenable. It's worth saying in Plato's time the idea of personality being linked with something that is unobservable in the physical world, or that, doesn't manifest itself physically, that seems very tenable. It's only really now that we know a lot more about the mind where we have to go, there is at least a very strong link between the physical mind and the self, and therefore choices. And as the physical mind obeys rules of quantum mechanics, then the lack of quantum mechanics allowing free will puts question marks over whether anything that makes decisions based upon the mind or any other physical system can possibly actually ever genuinely choose what they do. But anyway, we talked about a kind of Platonic, loosely speaking, idea of the soul. Now let's talk about a view of the soul which is more linked with Aristotle's idea, and I would argue is more consistent with what we know neurologically about the brain. So we talked about Plato's idea of the soul, and now let's go on to Aristotle's. And again, for this I'll be using the idea of a proposition and then discussing the consequences of it. Now, for Aristotle, the soul had a much tighter link with the physical world, or with specifically the body of an individual. And this idea is known as dualism, although dualism can mean many different things in different contexts. But the idea of dualism is that in some manner the physical body and the soul are related. They are not separate or independent things. And therefore, Aristotle's model of the soul isn't automatically ruled out by observations of drastic shifts in behaviour, commonly when people suffer severe brain injury. Now, Aristotle, perhaps taking inspiration from Plato, had an idea of a soul where the number 3 comes up again, but for Aristotle, the number 3 related to there being 3 different types of souls, which are related to the different types of living organisms there are. So some living organisms, like plants, can clearly observe the world and react to the world and seem very much to be living, but we don't think of them as being as rationally complex as a human. So a human has a different kind of soul to a plant, for example. There's a kind of hierarchy almost of souls. But, Aristotle had certain ideas about what experiences humans have that the soul might be responsible for, and what experiences people have that might be more linked with the body. But, for Aristotle, the soul and body kind of like work together to allow a human to be alive as a human and to be healthy doing so. So that's an overview of Aristotle's ideas. So with proposition 2, we're saying as a way to get around the problem of the physical world not being particularly accommodating of free will, with proposition 2 we might go, well, there's a soul and the soul is linked with the physical body, enough that severe damage to the physical body, particularly the brain, can cause drastic changes in personality and decision making. However, the soul is different to the body, and being different, it doesn't work in accordance with quantum mechanics or classical physics, and the soul is where things like free will can arise from. Now, immediately this idea seems more plausible. It's also worth saying, though, this idea is slightly nebulous, because it's not saying what mechanism the soul has to facilitate free will, or, how the body might contribute to the experience of free will, or there's lots of question marks. It's very vague, but it seems tenable. But my issue really with this idea is that the soul seems to be being used to fill out experiences, like the experiences of being able to choose something, that we can't explain by considering the body as some physical system and just stopping there yet, at least for definite. So for me, Aristotle's sort of notion of the soul, or a dualistic approach, is generally very vague about where the soul comes from, exactly the distinction of roles between the soul and the body, and how those roles might sometimes interlink. And the use of the soul is just being used to explain things that we experience, but we might not have at the time scientific understanding to otherwise explain. I mean, for example, like Aristotle thought that seeing might be an example of something the soul has an involvement in, but now we know a lot more about things like the optic nerve, we know a lot about the retina, and we now clearly understand that seeing things is a result of photons, so light, hitting the eye, and the eye essentially ultimately converting that detection into an electrical signal, which is sent to the brain, and then the brain constructs an image in relation to what has been detected. And we can clearly see that seeing is related to the body, because we now have a fairly good idea of things like, in certain substances at least, how things like colour blindness works through, a scientific understanding of the physical body. So, we don't need the soul to explain sight anymore, and it feels like maybe the soul in Aristotle's model is just a replacement for just a lack of scientific understanding. However, it's very difficult to rule out a dualistic approach. I feel that dualism has the same strengths-weakness in terms of it being ambiguous as, hypotheses like theism. So in the same way, it's very hard to rule out that God exists. It's similarly very hard to rule out that there isn't some, shall we say, supernatural essence of a person that is related or interacts with their physical body. It's very hard to rule that out. So, that's all I really have to say on Aristotle's model of the soul. But to wrap up what we've said, it seems like the soul doesn't seem a very good way of explaining how we can have free will. And then when we look at quantum mechanics, it seems like, well, maybe free will just isn't something that actually exists. Maybe free will is, in some sense, an illusion. And so a follow-up question to that is to ask, where might this illusion come from? Now, it's worth saying all the views I'm sharing on this video are just different ideas. I'm not going into my, personal views or opinions on the matter because, I think this kind of video is far more beneficial by me covering various perspectives rather than making a long video where I just talk about my own views. But I feel like, the natural course of research has led to the hypothesis, perhaps, that free will doesn't exist, and therefore the feeling of free will is illusionary. So one might ask, why? How is it that we could all, or at least most of us, have this very powerful sense of free will? I mean, free will isn't just something we vaguely, at times, when we're, in summer and feeling really thirsty, that just, comes upon us and we're like, ooh, suddenly I have a choice to go to the shops and get some, fresh grape juice or cranberry juice or something. Free will is a persistent feeling, and we attribute a great deal of value to the notion that people can choose what to do. So, where does this incredibly powerful feeling actually come from if free will is an illusion? And that's what I'm going to talk about to wrap up this whole video. So, why might things experience the sensation of free will if, for the purposes of this last bit of the video, we presume free will is an illusion? Well, it's worth saying the organ responsible for emotions and thoughts and feelings, including those about free will, the brain is incredibly complex. I think Sabine Hossenfeld described it as the most complex system we currently are aware of in the universe. That's not to say that the brain can do anything, or the brain is somehow fundamentally different to much simpler processes, but nonetheless the brain is incredibly complex because there's a huge number of neurons, there's a huge number of networks of neurons, there are different parts of the brain, there are plenty of areas of neurology where we don't really understand what parts of the brain are doing. I think even if we were able to reconstruct the human brain, we still wouldn't really properly understand what we are reconstructing. That is, even if we knew how it works, we might not really know why that combination of neural network works. So the brain is incredibly complicated. And due to that, sensations in the brain are very hard to reduce down to the fundamental rules of physics. In fact, it's so hard that I think it's reasonable that the brain could experience things, or think it's experiencing things at least, that seem outside of the rulebook for the fundamental physics which is ultimately behind all brain activity and ultimately all events in the universe. So it's not surprising when thought of in that way that one might be able to feel like one is free to choose things, even if fundamentally one is not. And it's because, the ladder up to the sensation of free will is so complex and convoluted, you can't really trace it back down to any deterministic rules or quantum mechanical rules in any practical reality. So practically, the sensation of free will does seem utterly disconnected from anything random, truly random, or anything deterministic. So I think that's important to emphasise. That is, free will might be permissible as an experience just due to the sheer complexity of the brain, which itself creates the illusion that certain things the brain is doing, like the apparency of being able to make choices, is actually, not connected to the laws of physics, where those laws seem not to have any room for free will. So that explains why we might feel, or why it might be, coherent to say we feel like we have free will, but free will is an illusion. But it doesn't explain why that illusion would develop and why it would develop across the whole of humanity. I mean, I think virtually every human believes or acts like they believe they have free will. Even people who don't think they have free will still act, or seem to act, as if they do. They at least talk about themselves and their actions or others as if free will is actually something that's real. So free will, or the experience of it, does seem ingrained into our psyche, to the point where even if we say we believe free will doesn't exist, our language and the way we go about our day seems to imply the very opposite. And I think the idea of free will may have developed because, the thinking one is free is, the equivalent of a, very beneficial mutation. It's not a mutation in genes, but it's a mutation in a manner of thinking about things. And that is because if one believes one is free, one is going to have more energy. And that's not out of choice, that's just a natural thing. If you believe you are free, you are probably going to feel more motivated whether you want to or not. You'll probably feel like you have more energy. You're going to probably be more easily in a naturally good state of mind. And therefore, you, by natural selection, due to natural selection, that adaptation, that experience of free will, is something that, will naturally be selected for, because you are more likely to survive, or you are more likely to be able to reproduce and care for offspring if you yourself are in a healthy disposition. And that includes the mind, as well as the body, because if you believe you have free will, you have more energy, you're going to be able to do more stuff, be that hunting for food, be that doing projects and learning more which will help you survive, or have more resources to pass on to offspring. Essentially, it is very beneficial for you to believe you have free will, even if you don't. And therefore, due to natural selection, it's kind of then inevitable that, if believing you have free will is a sufficiently big enough advantage, it's then kind of inevitable that that would just become, the proteins or genes or whatever it is that allow the mind to develop in such a way where it experiences free will, that will be, passed on to offspring and spread across the whole population eventually. So I think believing in free will is, in evolutionary terms, massively beneficial. And that may be why now practically every human feels, at least, like they have free will, because that feeling is, in very practical and very real terms, beneficial. But this leads me to the final conclusion of the video, because I'm aware that proposing that free will is an illusion, and saying it is just beneficial to believe one has free will, might be a bit of a downer. Now, firstly, I'm avoiding commenting on my, personal take on all of this. So there is more I could say on these matters. But I think the important thing is, even if we don't have free will, if anything, what the persistency and powerfulness of the illusion emphasizes is we are going to be able to live our best and happiest life if we just presume, for the sake of argument, that we have free will and respond accordingly. So, I don't think the notion of free will being an illusion needs to be as damning as the suggestion may at first sound. I think it's something that, if it turns out to be true, people can easily adapt to. I mean, there was a time where most people thought that humans were created directly by a god and were sat above creation, and now a lot of scientists think that humans evolved from other creatures, and so maybe humans aren't as divinely special as was once believed. And, at the time, the idea of interspecies evolution, particularly in its relation to humans, probably caused many people to have crises, but now people are just kind of fine with it. I think it's the same with free will. I think whatever the answer is, we'll be fine with it, because ultimately discovering something about reality doesn't change reality. All it does is make you wiser as to what reality is. And I think that is always a good thing and always something we should want. Because in the end, we can only make the world a better place if we continue to develop a clearer and more truthful understanding of what the world is. And that includes the nature of organisms such as you and me and the rest of life on our dear planet. So that's my conclusion for this video. I hope you have a very good day, evening, night or afternoon ahead, or morning, no matter when you watch this video, and I'm looking forward to sharing some wonderful physics soon. I've got videos which I'm hoping to make. I'm just at the moment doing lots of reading and learning lots of new things myself to hopefully, bring together some really good content for the YouTube channel and it's good for my work as well to keep myself up to date. But anyway, wishing you a brilliant time ahead, and I look forward to sharing with you some wonderful physics